Good evening. My name is Nakyambadde Mariam. I'm presenting Lendshield AI, and it's a predicting loan default risk module, and we're using machine learning. To this side. Good evening, Doctor. My name is Nakyambadde Mariam. I'm from group ML53. Evening. And presenting a predicting loan default risk using machine learning. So I've provided the link to my VS to access the code. It's right here. So I'll take you through the background and the introduction. Basically, this is a loan default. It's a loan default project. And we looked at financial risk being a big problem globally. So Lendshield AI is an ML system to predict loan default risk. So these are the references I used. And the problem statements I'm going to work with, we have how can financial institutions reduce loan losses and automate credit risk assessment using Lendshield AI? Number two, how can machine learning accurately predict borrower loan default from historical financial data? So after asking us all those questions, I came up with the research questions, and they were: which machine learning algorithm best predicts loan default from borrower data? What features most strongly influence loan default prediction? And how does model performance compare across logistic regression, random forest, and the XGBoost? To be a bit brief, I'll go straight into my findings. So this is the methodology and system architecture. Yeah, this is the Lendshield AI pipeline. As you can see, we first extracted data from the raw data set. Then I cleaned it. I performed feature engineering. I trained and split, and I got 80 by 20. Then I conducted a model training with logistic regression, random forests, and the XGBoost. I carried out an evaluation, and then I did a base model selection and prediction output. The data set description and exploratory data analysis is as follows. So I'll explain. Because I have limited time, I'll do it very fast. This is the data set, and then these are the records. I tapped 40 samples and I trained 80 by 20. The features that I used for these modules. I used loan amount, the interest rate, income, employment length, credit history, debt to income ratio, and loan purpose. Then the target was to know the default status and the no default, to know those that have like to predict the defaults that are going to happen, and also to know the rate at which the loans won't suffer defaulting. So that the 0 means no default and 2 means default. So in the EDA insights class imbalance, observe that class 0 is the no default, has 87.5% according to the data set that I have. And then class 2 is 12.5%, and that's the default. So at key predictors, we use the I use the debt to income ratio, the credit history length, and loan amount. Missing values handled via imputation, and all the features normalized using standard scalar. Because of time, I want to take you into the modules very fast. So I use the logistic regression as my first model. Because I'm dealing with numerical data, logistic regression is one of the fundamental models I have to use here. So this is a generalized linear model, and it assumes that the risk of default follows a linear relationship with your features. So this calculates a weighted sum of inputs. And the final regression shows that 97.50, as you can see here, this is I generated it from the cell output. When I ran the code, it showed me that 97.50% was the accuracy on the specific data set. And and to explain a bit, class 2 is 0.80. Yeah, this means that the project, the model caught 80% of the people who were going to default, and precision for class 2 was 1.00. This means when the model flagged someone as risky, they are definitely risky. No good borrowers were wrongly accused in this specific data set. Then when we go to the randoms, actually, before we go there, in logistic regression was not accurate enough. It didn't give me the accurate results because it had the data set was small. So I used the random forest, and the random forest, it handles linear messiness of lending data. So here, it deals with building independent decision trees, and each tree only sees a random subset of features and borrowers. This ensures the model does not just memorize specific borrowers like the borrower ID, as you can see from the graph. Then I continued to, to the expected results. And in credit risk, 100% is almost never realistic because it made that the model was looking at the future variables that a bank wouldn't have at the moment a person applies for a loan. Therefore, precision and recall were both by $1.0, meaning that it caught every single default without a single error. And this triggered the need for an audit. I continued to the explainable AI so that I verify and come to a conclusion with what I was training. So when I use the sharp interaction plots, I verified that the module's decisions are now based on the legitimate risk signals. I observed significant interactions between the branch ID, source circle, and company size, and this ensured that every credit decision made by Lendshield is not accurate but fully auditable and transparent for circle stakeholders, given the fact that I tapped only 40 samples from the data that was available. I couldn't come up with a full conclusion about what is happening globally. So this is the cell output, as you can see. So to continue, I also generated a clean confusion matrix to easily explain what was happening. The 4 quadrants in the confusion matrix categorizes every prediction into one of 4 buckets. In the 2 buckets are full and 2 are empty. As you can see, this is dark blue and this is light blue. Then these are plain white. So the model predicted the true negatives, top left was 35. The one that reaches the peak of 35, the model predicted no default. And then the borrowers indeed paid back the loans. That shows that was no default. These were the ones in the safe zone. And then the 2 positives, bottom right, the ones that have 5, yes, the model predicted default, and these borrowers did default. These ones, they didn't pay the loans, so the model did not wrongly choose anyone. No good borrowers were rejected. And then the false negatives left zeros that are in diagonal form. This is the most important number for the circle because the 0 means the model caught every single defaulter, not a single risk person snuck through the system. So with the conclusion, with explainable AI, it's basically the model basically categorizes people according to the default, those that won't default, and those that are not eligible to get the loans. So I carried out a model selection and deployment. As you can see, I justified that with logistic regression, it was 97.5% accuracy. And when we continue to the demonstration, user input borrowed data included the income, loan amount, credit history, and then the system preprocesses inputs and runs logistic regression module. And then the output was binary risk classification with probability score. The response was just 1 scan per prediction. And then in conclusion, Lendshield Ai successfully predicts loan default using machine learning. Logistic regression achieved 97.5% accuracy and is the recommended deployment model. Then random forest achieved 100% accuracy, indicating potential overfitting on the small dataset. Given the fact that I only collected 40 samples, it was small compared to the global data that we have. And the limitations I had was the small dataset. Yeah, the fact that I collected a small, the dataset had a lot of restrictions from where I extracted it from. So it was hard for me to get a lot of data since it was a government institution. So I also had a class imbalance of 87.5 to 12.5%. 87.5% are those that were not defaulting, and then 12.5% are those that were defaulting. This caused it's really imbalancing in the real world setting because I collected a few data samples. I think this turns out to be usable in the real world setting to reduce loan risks. And then lastly, the data set can be applied in the microfinanced institutions in Uganda, and also it can be used for sequential borrower behavior analysis, integrates sharp explainability for transparent loan decisions, deploy the APIs to help the African microfinance lenders. Thank you for listening. Have a good night.